Okay, awesome. Does anybody recognize this fictional company? It's from one of my favorite TV shows. Yes. Wow, that's pretty good. Yeah, it is Parks and. Oh, okay. You saw the other. I see. Okay, yeah, yeah. It's from Parks and Recreation. It's a company started by a character named Ron Swanson. And we don't have audio, so you're gonna get like a bad, like. I was gonna show a video, but like his vibe is, he's like a no nonsense kind of guy. So this video is supposed to be a commercial of him advertising for his company. It's a 30-second commercial, slot by that he did, and it's only 5 seconds long. And he says something like this: "If you use very good building construction company for your construction needs, or not, I'm not a beggar." And then he just sits there for 25 seconds. So he's just like a no nonsense kind of guy. And I think that Go is kind of like the Ron Swanson of programming languages. It's like just a no nonsense programming language, kind of like minimal, no frills. And an example is, so this is Rob Pike. If you don't recognize, but an example of this is kind of an old post on one of the Golang forums, and this is like somebody asking like, hey, like why can't I range over an integer like in Go? Like if I'm in Python, I can range over an integer like this. If I'm in Ruby, I can do it like this. If I'm in Kotlin, I can do it like this. And why doesn't this exist in Go? And Rob Pike, he said, hey, a for loop is called a for loop because looping is what it's for. Like just no nonsense, okay? This is a minimal language. We're not adding these frills, right? And so yeah, Rob Pike kind of reminds me of Ron Swanson. Now that's not like so Go is like it's the Ron Swanson of programming languages, and I'm not like I don't mean that as a criticism. I know this is a Go meetup. Like, don't throw tomatoes at me. I'm not criticizing. I really like Ron Swanson, and Ron Swanson's like a no nonsense guy, and like he builds really cool things. He's a woodworker. If you've never seen the show, and Go is kind of like that. It's like a minimal language, but it gives you the tools to build really cool things. And the thing that we needed to build at my company recently is we needed union types. And so that's what this talk's going to be about. It's going to be about how we created union types from Go structs using static analysis. So really quickly, I want to make sure everybody knows what union types are. So this is an example from TypeScript. If you imagine that you have a function and it takes in a parameter called padding. This is like for padding a string or something like that. And for the type annotation, you could pass any, but that's like not. That's a little bit more. You're basically turning type checking off, right? It's like not so great. So you can imagine padding taking number or string, and then the type annotation saying any, but it's like, it might be nicer to be able to say something like this, where it's like the second parameter padding is of type padding, and that type can be either a number or a string. Okay, so that's a union type. Now, if you know Go well, you might recall seeing something like this. This is from the generics documentation and example, where it's like, hey, Go already has something like union types. So you can say, you can have this, you can introduce a type that is it's a union of like integer, float, or string. But these union types can actually only be used in the context of generic type parameters. And so it doesn't really have first-class support for union types outside of that context. And if you don't believe me, here is the Golang team on kind of explicitly marking this limitation. And I think that they have an eye towards implementing union types like you see in other languages. You can see that at the end of this quote. Like they say, it's not hard to imagine how explicitly type-constrained interfaces might be useful in general. Yeah, you're right. It's not hard to imagine. This is available in a lot of other programming languages for a reason. Okay, that's what union types are. Our product is a part of it is this like workflow builder thing. Okay, so the workflow builder has forms, and it's got branches and some of these other things. So a form is like, oh, let's say there's a form that's like getting to know Matt. This is a horrible looking form, but it's like, do you want to get to know Matt? Yes or no? If you select yes, then there's a branch that will be evaluated. And if that branch evaluates to true, then the rest of the workflow executes. If it evaluates to false, then we skip everything else in the workflow. So if you think about this branch node here in the workflow, there are lots of in the branch node that must evaluate to true or false. And those expressions have different types. And so you can actually see this in the, oh, look at this, there's a little video, that's great. I forgot about this. So you can add, so this is an and expression. And I can have two different expressions here. One references a previous form value, and the other references a property of some other object. And so you can create these kind of complicated expressions in our UI. And of course, the UI is backed by an API. And so if you think about the type of the condition that the branch evaluates, it's a union type. You can have a literal expression, but you can also have ands, you can have aggregates, binary expressions, ors, nots. There's lots of different types that these expressions can take. Now, our API is backed by Huma. And you, does anybody use Huma here? No? Okay. It is specific. Yeah. I would say that it's like Go's like, it's kind of like Go's version of Fastify. But anyway, if you haven't used it, no worries. So Huma does this thing where it generates, open API compatible JSON YAML specs from the source code. So you get your documentation and you get schema validation for your payloads into the endpoints generated from the source code. Okay, and it's actually powered by reflection. Okay, but this kind of leaves us with a problem. Okay, so here's kind of breaking it down. Like, Go source can express union types. Okay, but our API has union types, and the docs and schema is generated from the source. So this leaves us in kind of a pickle. And because of the kind of these three things, if we didn't come up with a more clever solution, we'd be forced to write like a manual file like this, where this is like us telling Huma, hey, when you generate the documentation and schema validation for our expressions, it can be one of any of these things. So like we would have to manually maintain a file like this in order to get the correct documentation and schema validation. But that would be a bummer if we did the things manually, and like there wouldn't be an interesting talk here. And so when I first joined the company, my boss was like, hey, like it would be nice if we didn't have to do this. And what's more, it would be nice if when we added a new expression type, it'd be nice if the compiler yelled at us. Like we had some help to know that, hey, you need to like to update the schema, validation generation or the docs generation. Now, when I saw this, I was very excited when he sent me this message because I knew that it meant that I get to work with abstract syntax trees. I knew that I would get to mess with this. So abstract syntax trees are really neat. AST for short. There's actually an AST package in Go that makes it really easy to work with this sort of stuff. And so here's like kind of a hello world of working with an AST. And so here we are, we're simply kind of like parsing a Go file, and then we can just dump out the tree representation of the source code. And so here's kind of what this looks like concretely. So on the right, or sorry, on the left, on your left, we have some source code, and on the right, we have the tree that it corresponds to. And so if we look at just the package, that's going to correspond to this part of the tree. And so there's for every little line or even part of a line in the source file, there's a node in the tree, and this gives us a much kind of nicer and structured way of working with the code. We can transform the tree. We can do all sorts of operations, analyze the code in a very structured way, instead of just writing like random regexes. Right? There's like that saying like you have a problem and then you use regex and now you have two problems. Like we don't want to avoid that. We want to have like a nice kind of structured tree for analyzing our source code. And so here's the part of the tree that corresponds to the main function declaration is here in the AST, and you can see that there's there's a node that is called, it has type pointer to function declaration. There's a node that's called ident for identifier, and so the function has an identifier. The name of it is main. And then you can see, it's probably hard to see, but I'm highlighting the parentheses here. You can see that there's a node here for a field list, and it happens to be an empty field list, but you get all these really nice kind of nodes for the parts of the source code. It even tells you the lines and columns that they live at in the source file. And then more, I will just show like the nodes for print line. So that's going to correspond to the body of this main function. There's a list of statements. The first one is an expression statement. It's a call to a function called printline, and one of the arguments of that function is the string hello. You can see that in the tree there. So pretty neat. Now, okay, so now we have this AST package where we can analyze a source file or a set of source files. Our expressions are all different implementations of an interface in Go. Now, you might think like, oh, you can analyze the tree of these files. Like, it's really trivial to find implementers of the interface. Unless you know Go well, you wouldn't think that. But like, if you come from a language like Java or Kotlin, where you're explicitly declaring that a type implements an interface, then finding types that implement the interface is like, well, you're just looking for this implements, expression clause, right? But Go is a very good programming language. It's a no nonsense, no frills programming language, which means structured type system. We do not explicitly declare that we're going to implement an interface, right? We just, if the type has all of the methods of the interface, then it satisfies the interface. And so this makes our job a little bit harder when we have to scan the source code and find all the implementers of an interface, so that we can generate the union type for the docs and the right schema validation. Okay, even with that little wrinkle though, Go's AST package is so great that it only takes about 137 lines of code with comments to write the static analysis that will generate the docs and the schema that we want for this. And so I want to take you through one interesting method within those 137 lines. Sorry, it's actually a function, to kind of just dive a little bit deeper into how this works, and to kind of show how easy it is to get started with static analysis. So the function we're going to look at, I called inspect interface method declaration. The inspect kind of prefix in that function name will make more sense when we dive into this. So kind of looking at the body of this function, we can see that it's actually really, so once you've parsed a file, it's, sorry, do you have a question? No worries. If I'm moving too fast, let me know. Sometimes I get excited and I just like, but yeah, and also, does anybody have any questions before this might be a good stopping point to check, make sure everybody's, this is actual Go code, yes. Yeah. So we're gonna walk through it line by line, no worries. Like, it's like the top part you can just ignore. I'm just talking about the top line. Okay, so once you've parsed a file using the AST package, there's a property of the struct that's returned called DECLS. Is more like no frills nonsense. You don't get the full name. It's like Rob Pike definitely didn't like Java, where it's like long names. Like that's what you get. So that stands for declaration. So you can range over all of the declarations within a source file. And so that's what we're going to do, right? We have to look at all of our files, and then I'm interested in all the declarations within that file. And then I can, this is like type switching in Golang. If you're not familiar, I can say, hey, if the declaration that I'm currently ranging over is a function declaration, then I'm definitely interested in like kind of examining the tree further to see if it's the declaration of a function that satisfies the interface, the expression interface type, right? And so then here I can check, okay, it's not just a function declaration, but it is a function declaration whose name matches one of the method names from the interface, okay? So that's easy enough to check. And then there's this nice function in the AST package called inspect, where you can give it a node in the AST, and it will basically recursively traverse the tree and call a function that you pass in order for you to do something, so to do some kind of analysis or some kind of transformation. So that's really handy, because then you don't have to like, kind of basically do a lot of type switching and like understand the structure of every intermediary node from where you are to where you're trying to get to. It'll just recursively traverse the tree for you, and we'll see this actually here as an example. So so let's say you have at this point in the code, we're kind of looking at a function declaration, and we're at this node of like receiver list, and we can actually the inspect function will let us jump all the way down into this this type node in the tree where we have this and expression type, right? And we don't have to worry about any of the intermediary stuff. It's gonna recursively traverse for us. So inspect is neat. And so so now let's look at the function that we actually pass into inspect. And so here we're going to do another type switch, and this time we're basically there's two types of identifiers that that could be inside of the function declaration. There could be the variables for the parameters, but there could also be the identifier for the receiver. And so here I'm just saying, like, I'm not interested in the names for the variables. I'm interested in the name for the receiver because that's going to tell me if that matches the. Go ahead.
Yeah. So I know that there's some people in the crowd that don't write a whole lot of Go. Can you clarify what a receiver is?
Yeah, great question. So so a receiver is what's the language that people write here? Is it like, I'm trying to make an analogy maybe to another language. It's like Python. Is C or Python? Yeah. Okay. So a receiver, you get, like, when you're using Python, you have self, right? That's what it's called, self. If you're doing Java, it's this. If you're doing JavaScript, it's this. Okay, so the receiver in Go is like the self or the this. And so when you're looking at, actually, it would be nice if I could show a like a method declaration really quickly. Maybe I will. So if I go to, like, let's go to and expression. Yes, that's right. Yeah, so if I go to, like, exists. Okay, yeah, so so here we have this, there's this type, it's an exists expression, okay? And when you declare a method on this type, this is your receiver declaration right here. So you're saying, hey, the receiver of this is an exists expression struct. And so instead of saying this or self, you do C. You can name it whatever you want, but that's essentially what's going on there. Does that make sense?
C++, this is always a pointer. Is that the case?
Not necessarily in Go. Good question. Yeah, so the pointer, the receiver could be a value type. It doesn't have to be a pointer. And you're like, you're making a face.
So if you mutate it, then it doesn't.
That's right. That's right.
Okay, so expected behavior is expected. Nice.
Yeah. It's sane. It's sane. It's not. Yeah, it's not too wild. So, okay. So let me, if I can get this going again. Give me one sec. Because it's not a programming language. Uh-oh, we got some Go haters in the house, apparently. Okay, so that was a little bit of hand waving. I'm happy to talk more about that. But we have the code to do the static analysis. Go has a really neat kind of facility for essentially running binaries as a part of a kind of a pre-processing step before you run the compiler. And that's actually what we see here in this directive. So we can see that at the top of our expression interface declaration, what I'm essentially telling the Go preprocessor, if you will, is, hey, when we run Go generate, you should run this command, go run, and then I just point it to the main that contains the code that does the static analysis. And so the effect of this is essentially when I put this comment here and I run Go generate, I can do the static analysis and then generate this file for Huma. And so I don't need, you can see at the very top, it says code generated by CMD, blah, 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 do not edit. And so now I don't need to manually maintain this file. I will get the correct documentation. I will get the correct schema validation. Sorry, should I be standing here? I don't know, like, okay, it doesn't matter, yeah. I just have, like, almost done with the presentation. But yeah, so then this just gets generated. And, like, if you're curious about this, kind of how exactly this gets generated, we're just using Go templates. I'm happy to like talk more about that if that's interesting, but I think that part of the language is a little bit more straightforward than the static analysis piece. So, but yeah, it's like do the static analysis, then you have the information you need to kind of fill out the template, and then boom, you get this file. So including the templating code, okay, all of this is actually 148 lines of code if you include the templating part of it. And so it's really not that much work, and you have something that's pretty awesome. And so that like Golang is like the Ron Swanson of programming languages, no frills, no nonsense, but you have everything you need to build cool stuff. And that is my talk. So yeah. So I guess we can, if more questions, if people are interested. Yeah. Yeah. Sure. Yes. It is. Yes. Yes. Yeah.
So does Go have the other union type, like the way the C and C++ have a union?
Mm-mm.
Okay,
No.
so
Yeah.
answer my question.
Okay. Cool. Cool. Anyone else? Sure.
So that 148 lines of code, that's code that you write yourself?
Yes. Yes.
Yeah.
I can show you. It's actually a little more. Since I did this presentation, since I put together the presentation, my boss added something. So I think currently it's not very much. I think he said something like time box it a day or something. And so I was like, okay, I'll see what I can do. So this is, here it is right here. So it is current, it's actually 162 right now with comments. So it's not so bad. And then here's the template file, if you're interested. Here it is. So not so bad. Oh, can you see that? Yes, you can. Good. Yeah.
So the AST searches for an implementation of an interface. Because like you said, it's implicitly defined, like if an implementable method is a function, then
that's right. Yeah, that's right. So the AST basically it looks at, so like, yeah, maybe this probably wasn't super clear, but like if we go to the expression file, okay, so there's this interface. So the one thing that's nice that I kind of forgot to mention is Go generate will pass useful information into this executable, like the path of the file that this comment came from. And so it's like really easy to be like, oh, just like look at the AST for this file, give me all of the names of these methods, okay? And then I know that this file is inside of the expression package. Look at every file inside of the expression package, and then look at the ASTs for those, and look for things that implement all of these methods. And that's kind of what we saw with the function that I took you through, the inspect method declarations or whatever I called it.
So all the types that implements this interface.
Yeah.
Those are the things that gets union together.
That's correct. Okay. That's correct. Yes. Yep.
So you're not using AST as a hacker way of saying, okay, I'm going to define my own syntax for defining a union, because that will make the compiler itself. That's
right. Yeah. So we're not like the Go compiler doesn't care at all about what we're doing here. It's really as an input into Huma, because Huma. So if I go back to this, let me go back to this this slide here. So Huma does two things for us. That's kind of nice. One is so when we're looking at the documentation for an endpoint, and there's this like branch condition that you can pass into the payload. That's a type that has a type, right? And the branch condition can be any of these expressions. If we don't give Huma that like that auto-generated file, it doesn't know what to put in this dropdown. It doesn't know like, oh, this is a union type. There's like it can be any types as a valid thing that gets passed into this endpoint. And so the first thing is documentation, but the second thing is just the schema validation. So like the runtime check that whoever calls endpoint is passing in a branch condition that is shaped as a union of one of these things, if that makes sense. So you can't just pass in like garbage. Like if we was just any, then it's like, well, you can just give our API whatever you want, and we have no guarantee of what the shape of the data is. But because we've told Huma like, hey, this is what the union type looks like, we get the schema validation in the docs. So this is a long-winded way of saying that like the union type that we're kind of creating, it's just for like the Huma stuff. It's not, the Go compiler doesn't care. Yeah. Sure.
Yeah, so traditionally, you use the right language for the right job.
Sure.
Conversely, language tries to seek its own niche. So
Sure.
you have a union type already exists as STD variant in C++.
Sure.
And Go tends to be used for, I guess, to some extent, rapid prototyping, like Ruby, which has a union type.
Sure.
And things that need high level of scale, like Rust, which also has a union type.
Right.
So, how does this change why or how people should choose Go over other languages?
It's a joke. It's really good.
Yeah, Docker.
Yeah.
Also written in Go.
If you're writing extensions, you can. But that's just my experience.
Yeah. So I think your question is like, maybe it's like, did you pick the wrong language if you had to do all this or something? Is that like is that like a fair? Sure.
I just wonder about the decision calculus of what is Go is good for. How does having union types in language change that?
Sure. So I think I can speak to like my boss's motivation for picking Go. So like I think this is a pretty common reason why people pick Go, is that it's the Ron Swanson baby. It's like there's not a lot of nonsense, so it's easy to learn quickly. And so that was a huge factor in why my boss chose the language. Was just like, hey, we're going to be hiring a bunch of people. The language is like easy to learn. We're not going to have any problems with that. So I think that's an area where Go shines. I think another area with concurrency and channels. I think that's a huge kind of benefit. I would say those are like the two main reasons to pick Go. Yeah.
Your alternative is to use C and use everything as void points.
Go ahead.
Just listen off the things about Go. I was an editor, so.
Could you pull up that final document that it produced?
Sure, yeah. So you're talking about, actually here, I went too fast. You're talking about, hold on one sec. It's this thing. You're talking about this, yeah. Yeah, it's, sorry, I didn't intend this to be scrutinized. It's like a part of the point, right? It's like, I don't want to have to worry about the details of this, like just generate it. Yeah, this is just generate, but this is just like getting into the weeds of how Huma works. So this is just like how Huma wants you to tell it like, hey, I have this union type. And really this derives from the open APIs, right? Like open APIs, like they understand that there needs to be a way to express union types for your API. And so this really just mirrors how open API thinks about union types for API specifications. But you can see that like Huma, you can see here, like there's all these reflects, right? So Huma uses reflection for its analysis of the code to generate the schema and the documentation. And I actually think if I didn't have two kids, like there would be an open source project that would be like Huma, but instead of using reflection, it'd be static analysis, because you can just do more. With reflection, you're limited to the reflection API. But with static analysis, you can do things like union type generation fairly trivially. Go ahead.
So if you were using a tool other than Huma,
Yeah.
you would likely still have the same issue because union types don't exist. So
That's right.
maybe the end result would look a little bit different because it has to match
Right.
what cool means, but it would still be something like this.
That's right. Any web framework that tries to derive types from Go source code is going to have the same problem. Union types don't exist in the source code. It's just the concept isn't really there. So you need to kind of bolt it on. Yeah, go ahead.
Does Go have an option for like literal options? So, for example, it could be like a literal string 1, and then another literal string 2, and a literal string 3, and then you can only choose between those two. Kind of like an enum.
You can do enums. You can do enums, but there's no like.
There's not a syntactical thing that lets you do like
That's right. That's right. Yeah. Sorry, I think you made a comment that I don't know if it was appreciated. I kind of moved on. And go ahead.
I was just mentioning that we get
Oh, okay. Interesting.
so like you'll define like I want these critical types, and then they'll thousands of thousands.
Oh, interesting. Okay, cool. I didn't know that. That's I'll have to check that out. That's interesting. Any other? Yeah. Uh-oh.
No, I'm just thinking how to put the question.
Okay.
In C, C++, I'm not sure where this is what you're getting at. Union means something very specific
Sure.
in terms of different variables occupying the same physical space.
Hmm.
So I just want to kind of verify, in this case, you're more thinking of union in terms of an abstract, logical idea of, well, all this stuff that has the same interface, I can describe externally and don't have to pick the content type by that description. I let the underlying implementation take the specific concrete type. Not that they share any kind of co-location in memory or
That's right.
each other or anything like that.
Yeah, that's right. Yeah, it really has nothing to do with like memory layout or anything. It's just like it's like a type checking kind of nicety. Yeah.
I only say that because it confused me walking in the door, because coming from a background where I wrote C for 12 years,
Sure.
a while back now, I had in mind what is the union type in C.
Yeah.
And I knew that the code didn't do it, so okay, well, what is he going to talk about here?
I see. Yeah. Sorry for the confusion. Yeah, it actually this is really clear in.
So I did ask that previously. Like, does Go have that version of a union where you can reinterpret that set of bytes as different types?
Oh, okay. So yeah, I think we would call that like a type conversion or something. And so yeah, you can like.
You're not doing a type conversion. You're reinterpreting the layout of the bits.
Sure. Yeah. Fair enough. Yeah. That is like, yes, I think we're talking, and that does exist. So you can say like, I have these bytes, compile it like, originally the type of it was int, shut up compiler, I'm going to reinterpret this as something else. Yeah, or something like that. Yeah.
It's a type in the sense that it's like a typeless type. So, everything is an any. So yeah, you can cast any for the interface.
And then you can cast like an integer to an any and an any back like a float.
Yes.
Now
That doesn't mean that it's going to work. And that said, Go does have some niceness on that. You can put an extra argument that says cast this into a float, but also check to make sure that it's able to be casted into a float. And if it can't, then we can handle that error. So.
Yeah. Any other questions, thoughts? Yeah.
So I got another dumb question for you.
It's probably not, but okay.
So who's Go easiest to learn, or is it like Python programmers?
Oh man. I don't know. That's a good question. I think I honestly it feels very similar to C to me. Because I think the thing that trips up a lot of folks with Go is like pointers. That might be the hardest part about learning the language. And so if you're already familiar with that with C, that I think it's like a pretty easy thing to pick up. Yeah.
Wasn't Go developed at Google?
Yes.
Because senior developers saying younger developers had a difficult time picking up C and kind of felt that niche.
No, I think the motivation was actually related to compile times. So if I remember correctly, compiling C++ was just really slow. They had a lot of C++ at Google. And so like, actually a lot of the like Ron Swanson-esque nature of the language is like, hey, if we had this language feature, the compile would be slower. And ain't nobody got time for that. So like, we're just gonna keep it simple and make the compile times fast. So I think that was the main motivation. But I'm not an expert on Go history, so. Yeah. The developers playing with swords. What are you doing? It's compiling. Okay, it's fine. Yeah.
For the room?
I think one of the creators just left Google.
Oh, interesting.
Yeah.
Oh, yeah?
I missed that.
Huh. What's the, is there any T there?
I
Or?
don't think so. I think that he's just moving on.
Okay, fair enough.
Was he the young one?
Well, maybe relative to the others.
Yeah, that's what I'm saying.
No, I don't think so. I think that he's older than probably. I don't know for sure.
Oh, yeah. So one thing I wanted to quickly say here with this TypeScript slide is like, yeah, I think one thing that really drives home the idea that like we're talking about a type checking thing or a compile time construct is like, so the whole idea of TypeScript, right, is that it goes away at runtime, right? It's just like, it's nothing. It's just a bolt on to JavaScript. And so the union type idea here, yeah, it's all just in TypeScript land, like as a type annotation. At runtime, it's nothing. It has nothing to do with like memory layout or anything. It's just a way of avoiding mistakes on the program or, yeah. Yeah, I stolen from the TypeScript documentation, so I can't take credit. But yeah. Cool. Thanks for coming, guys. Thanks for listening and the questions. These are great questions.